Alright, BC. Number 1 for the 25-minute question put together by, I believe, and if I am not giving credit to the right person, I apologize greatly, one Jeff Osborne through the AP College Board communal website, communal blog, communal email, whatever you feel like calling it. He threw these together in an effort to say this is what I think the test might look like, and we're very thankful to him, and this is me working through it. So, gives himself a graph here. You've got a straight line, a quarter circle, straight line, and a curvy line, which is 32 over x squared. Also, f of 0 equals 5. So what I always do is make sure I am very clear. This is the, and I don't know why it doesn't want to copy all this. This is the derivative, and the integral, exclamation points, integral of f prime of x is f, and my computer hasn't caught up with me yet. In a minute my handwriting will improve a great deal, and the derivative is the second derivative. So derivative of f prime, of course, is second derivative. So let's see what we got. It says final x values for relative max and relative min. So we're looking for the zeros here, 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 and not this one because it doesn't drop. So that is at x equals 1. So at x equals 1, the derivative goes from positive to negative. So we're looking at positive, negative, so that's going to be a max. So we're going to go with a relative max and make sure we read the question. Find the x value for relative max at x equals 1. And then at x equals 3, the derivative goes from negative to positive. So it's going to be a relative min at x equals 3. Alright, now I'm going to lose my drawing, so hopefully you have a copy of this in front of you. Otherwise I would do a screenshot or something like that to make sure you know what you're looking at here. It says find points of inflection. So we're looking for mins and maxes on the graph, and I'll go back up. We have a min here, a max here, a min here, and a max here. So we have to check out those spots, and actually we can basically say that they're all max and min. So I wrote down find, I call it max and mins, but if you feel like it, peaks, valleys on f prime of x, x equals -2, 0, 2, 4, and then I would say there is a POI at x equals -2, 0, 2, 4, and I'm going to stop right now and say on the interval find all x values. So they don't want the y values or the f of x values, and I'm going to say because the graph of f prime of x goes from negative to positive or positive to negative at each point. I would write much more clearly than this, but it's a limited technology I'm working with. Write an expression, and we're on the next page, which again Jeff did a really wonderful job of bringing the graph to the next page so you don't have to flip back and forth. It says write an expression that includes an integral, and this is right off the College Board, so he did his homework and he knows exactly how they do their work. To find the values of f1, that includes, write an expression for f of x that includes an integral. So that one's pretty straightforward. F of x equals the integral from we're given f of 0 equals 5 up top. So we start at 0 and go to x, and we're integrating, like I said earlier, f prime of x, and then we add 5. And Jeff's answer key puts the 5 out front. It does not matter. I don't know why, I just like putting the 5 at the end. So how do we find f of 1? So start at 0 and go to 1. So if we start at 0 here and go that way, 1 is right there, so it's all positive because it's above the graph and we're going to the right. And it is just very simply, I want to make sure I do this right. Yeah, 1/2 of 1 times 2, so that's all of that right there. Plus 5, which is 6. And then f of 3, same thing, 1/2, 1, 2, and then there's a plus 5 out here. But now we look up and we say as we pass here, all of this is below the graph. So that's going to be negative. So it's negative 1/2. And I believe the first time we did this I broke it into 2 pieces, which is not a horrible thing to do, but I made my life a little easier saying base is 2, height is 2, and we blast that out, we should get 4. That's it. Now on the interval, find the absolute minimum and absolute maximum, and notice the beauty of the design of the problem. We've already done 1 and 3, which are relative maxes and mins, so let's write them down. F of 1 equals 6 and f of 3 equals 4. Alright, so I'm going to justify in advance. I'm going to say check endpoints and local relative maxes mins. And let's reread the question. Absolute max and absolute min. He wants them both. Good for him. So we have to check out what f of 4 is. Now we're going left of 0. All right, we've got a quarter circle right there. So we do that first. Pardon me, that's f of negative 4 is the endpoint. Start at 0, go left, and that would be, I feel like I'm making a mistake here. No, that's right. It's a quarter circle, so negative 1/4 pi r squared, and the r is 2. Now we're still going left, we're still above the graph, so left from 0 above the graph is negative, minus 1/2, another triangle, and that would be 2 times 4, equals, blast it all out, oh, whoa, got ahead of myself there, plus 5. That would give you 1 minus pi. And that, we'll find out in a minute or so, is going to be your absolute min, I believe. 1 minus pi is like negative 2.14. Now, I can't actually say it now. I'd have to do the last piece, but absolute min, and I like to do it this way, at x equals negative 4 of 1 minus pi. And they ask for that. They don't ask for the x value. They ask for the absolute min. So I could actually skip that at x equals negative 4, but I find it's a good habit. Last one, let's get rid of this nonsense so we can write more clearly. F of 6 equals, alright, so now we're going to the right, and we've got, I'm going to start, I'm not going to start at 3. We've got the whole 1/2, I really shouldn't have to write all this out, but hey, whatever, 1/2, 1 times 2, and then minus 1/2, 2 times 2, and then plus 1/2, and that's 1 times 2, and then plus the integral from 4 to 6, $32, and I always write it up top so it helps me do the calculus, and then plus 5. Alright, so 1, negative 1, 0, so we have 5 here. Let's see what I got. If I'm doing that right. No, I'm doing it wrong. So start there, cancel, 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 cancel. No, I'm right. So it's 5. Where am I getting 13 from? Oh, that's inside the integral. Whew, let's see now. Well, let's just do this piece right here, and kind of running out of space. So add 1, -1, divide by negative, we get -32 over x from 4 to 6, which is -32 over 6, 3, -16, minus -32 over 4, which is 1, which is 8, all right, plus 5. So we have all of this plus 5. 8 plus 5 is 13. That's where I got my 13 from. 13 minus 16 thirds. Might as well do this right. 39 over 3, and we get 23 thirds. All right. And now I'm feeling a little worn out, a little tired, a little, wow, this is taking forever. Yeah, it's a tough problem. Now it says find the area from 4 on. So the integral 4 to infinity of 32 over x squared dx. I warned my students, I'm sure they didn't listen, you have to write this as a limit, and I used a, but Jeff used b, which is totally fine. A goes to infinity, integral from 4 to a, and again I'll put it up high, 32x to negative first, equals -32 over x, that's the second, integral is that from 4 to a, forgot it already, limit as a goes to infinity, notice my horrible limit sign, equals limit as a goes to infinity, -32 over a minus -32 over 4, boom, boom, plug in infinity, becomes 0, equals 8. Cool math. So that's it. Hopefully you did fairly well on this. Make sure you grade it. I don't have my points here, but you can use the answer key that I posted. And I would love it if that was a problem on the test, because I think you all would ace it. Unless you have no idea what you're doing, in which case you don't deserve to ace it. But there's a lot that should be very clear to you there. And also notice you didn't need a calculator, really don't need notes. I mean, if you know it, you know it. If you're tearing through your notes looking for answers, you're out of time. So you've got to just be able to do it relatively quickly. One of the things I did actually fairly well on here, if I do say so myself, which I usually don't, is I wrote out all my reasons very briefly, concisely, and clearly, except for my horrendous handwriting. So that's something I would definitely follow. Good luck.